expression, the formula that we were going to use for a triangle. What is that? What is that formula? Go ahead.
Base times height.
Okay, so we have, where is that base at, Hayden?
Where it sits.
Where it sits on its base. So is this okay?
Yeah.
Where's that height at?
It's the side.
What side?
This one.
The side that is going straight or the side that
This
is
side-
slanted?
This side going straight.
Side that's going straight. So here we have our base and our height. Is there anything else? So he said base times height. Is that all? Riley,
Divided by 2.
we want to divide this by 2. What's another way that I could write this? Cord.
1/2 and then parentheses and then b times h.
Okay. Would you want to go up here using this other, what you have here, and explain why it is base times height divided by 2?
It's base times height divided by 2 because if you cut this cube
Go ahead.
square in half, so if you cut it in half, then you take away that, and so then this would be the base times the height, so then you just have to take that away.
How many agree with what she said? Perfect. Okay, thank you very much. This was a good review. Okay, so can I get you to erase that board for me, please? Thank you very much. Okay, so today, here's what we are going to do. It says students will recall how they came to find the area of a triangle, right? And a parallelogram by composing and decomposing shapes. So we're going to recall how we did this, and we're going to use this information to help create the formula for a trapezoid. So I'm going to give you a shape here, 2 shapes to be exact. You're so welcome. You're welcome.
Thank you.
Okay, so you and your neighbor, and if you don't have a neighbor, you might want to slide. You might want to slide around. You might want to slide down. Right there, right there, right there. Slide down. Here we go. Okay, so what you have in front of you are these 2 shapes. They look different, don't they? Anybody tell me what shape is that? Talk to your neighbor. Tell your neighbor what shape you think that is. Be sure you can tell me why it is what it is. Share with me. Eyes here. Colin, what did you say this shape is? That shape is a trapezoid. How many agree? Thumbs up. Perfect. Who can tell me why it's a trapezoid? What makes it special? Madison. Can you say that a little bit louder for us? It has 2 parallel lines or one set of parallel lines. One set, one set. They don't look exactly the same though, do they? But they are trapezoids because they have one set of parallel lines, and how many sides are there? 4. So it's a special quadrilateral, isn't it? Okay, so taking a look at that, we want to come up with a formula. Now think about what you did with the triangle to find the formula. Okay? We just did it. Use what you know to try and come up with an expression, a formula that you can use for the area of these trapezoids. Now remember, does a formula have to work for every quadrilateral?
Yeah.
Does it have, it has to work for this quadrilateral, no matter, every trapezoid, I guess is what I should have said, every trapezoid, this formula should work for. So you and your partner, I don't care if you need to cut something out, I don't care if you need to trace it, you do what you have to do to come up with this formula. Go. You and your neighbor.
I think base times height for the bottom one. Because if you think about it, like right here would be the height. So, and then you would have the base So base times height, and then if you took this part off over here and added it to this side, we'd make a rectangle. So for the bottom one, think about it. So right here would be like the height. Yeah, and then over here, it would make a full triangle. Rectangle, yeah. But it'd be base times height. Because you could still do base times height up here. But then you have a part added to this rectangle out of it.
So, how are we gonna make
Because
sure?
honestly, right here would be the height, and this would be the base. Base times height. And then you have just that little bit right there.
Where is your base?
Divided by 2.
You would have the time, okay? Now, so we have base, we have another base. What if I did this?
Because if you add
Upside down. So what do we have? Think about that. How can you, and also apply what you did with the triangle. What did we do with the triangle? Well, but what about a triangle? What gave us that formula? What did you just say? Oh, think about what you did with the triangle. Okay, I see some really good things, but I see some kids that maybe you're trying to decompose the triangle, right? I'm going to show you something just to give a little hint. If I have this, what did we do with that triangle? Who remembers what we did with that triangle? If I remember when I had the triangle up here, remember that? And then we put this other one over here. Okay, remember we want to use what we know. Okay, so if I put this here and I have another one of these, if I have 2 of these, how can I use both of those to possibly come up with that area? Mr. Neiman, do you want to come up here and show us? What would you maybe do? Oh my goodness, who sees that? Oh boy, okay, I'm just gonna make this a little bit more clear here. Oh my gosh, what do we have now? What do we have now? Phoenix.
Parallelogram.
We have a parallelogram. Now, don't we need, if we're gonna do a formula, don't we need some variables? What do we want our variables to be? So for example, here's this trapezoid right here. This right here. What do we want to call that? Hayden.
a base.
A base. Do we have anything else? See, don't we have another base?
Yeah.
Yeah, I'm gonna make that a different color. So here's another base. But can we label it a base?
No, it's base.
Phase 2.
We need 2 of them, don't we?
Base 1 and base 2.
So do you want, we'll do base 1, base 2. So base 1, and we'll do base 2. What else do we need then? Let's talk about a parallelogram. So now that we flip this, what do we have up here now?
Base 1.
Base 1. And what do we have down here?
Base 2.
Base 2. How do we find the area of a parallelogram? What's that formula? Who recalls? Yes, Anna?
Base 1 times height plus base 2 times.
Just a parallelogram. Because isn't that a whole parallelogram? How do we find the area of a parallelogram? What's that formula? Do you remember?
Base times.
Thank you. So a parallelogram is base times height. So if we have a parallelogram here, talk to your neighbors now. What do you think that formula is going to be to find that one trapezoid then? Look at there, that's much better. Remember that? What you got? What's this? But what is this? You actually measured it? You just gave it a fake measurement? Gotcha. How many think they have that formula? How many? Oh, we're still a little shaky. Huh? Colin, will you come up here for us? Write what you want that to be, please. What do you think about that? Does anybody have another way they'd like to write that? Another way that that could look? Go ahead, Hayden. Are those the same? Is there another way to write it? Chord. Go see if there's another way you could find that same information. What do you think? 1/2 of the height of base 1 plus base 2. Do you agree with that? How many agree with those? Ooh, what, is there something to fix? Hayden, what do you want to fix?
The 1/2 should go at the end of it.
It doesn't really, does it have to? No. It doesn't have to. Nope, it's okay. It's okay. Are we good? Okay, so now, here's what I'm gonna do. So we did it with this shape, right? I want you to look at this one. So now let's look at this and let's test our formula. Should we test it?
Yeah.
Okay, so now I'm gonna give you some measurements. Okay, so I'm gonna give you some measurements. I'm gonna do my best here to make these precise. So let's say here that we have this base 1. Base 1 is going to be 11 centimeters. We're gonna go here, and this base right here, we will give 7 centimeters. What's another measurement that I'm gonna have here? What am I gonna have? Let's see, Mr. Neiman. The height. Do you want me to, I'm gonna come over here, is that what I'm doing?
The one that's straight up.
Oh, because a slant can never be a what? Height, that'll be like asking somebody where the ladder is against the house, right? We want it straight up, correct? Not leaning. Okay, so our height is going to be, let's do 2.5. All right, so now, you and your friend use that formula, and I'll write it back up here again. Who can tell me again what that was? Tell me one more time. Andrew, what is it? What's that formula? Do you remember?
Base times height.
Well, base times height, but how many bases?
2.
So what do we want to call those?
Base 1.
Okay, so we have base 1. plus
Base 2
base 2. What are we gonna do with those?
divided by 2
We have to take them times something first.
times a half, 1/2.
No, try again. Someone help him out. Help him out. Yeah.
Times height.
Times the height, right? It's kind of like a rectangle. Base times height. So times the height. Now what do we want to do?
Divided by 2.
Divide by 2. So there's your formula. Apply that formula and see if that's going to work. See what you get. When you get the answer, check with your neighbor. See if your math is correct.
Yeah, 42. And then you have to divide that.
So what do you get when you take base 1 plus base 2? Times your, which is, okay, so do that math. 18 times 2.5. You better do 18 times 2.5. When you're done, thumbs up so I can look. Might want to try that one more time. 18 2 times is what? Plus another half of 5. Half of 18. Try again, yep. What do you got there, girl? Okay, so what does this equal? So 18 times 2.5, what's that equal? You better do it. Nice. Are you there yet? Yep. Where is it? Yes, yes. Close. Honey, do you need a decimal? Do you need to line up your decimals when you're multiplying? No? Be careful. Not quite. You have a little too much here. Where'd you get when you, are you multiplying your base and your height or adding them? Yeah, I think maybe you multiplied yours there. Okay, so how can we then use a formula? What do I need to do here? What am I going to replace for base 1 and base 2? What do you want me to do, Riley? Yeah, I'm going to replace 7 and 11. It's just like solving using order of operations, isn't it? What am I going to do here for my height? What am I going to replace for that? I just put it in place of it. 2.5. And what am I going to, then I have divide by 2. So here's what I have now. 7 plus 11 times 2.5 divided by 2. Don't we need to apply our order of operations? Look at all of the things we have to know how to do here. We have to know how to do expressions. We have to know how to evaluate an expression by order of operations. Do we need to know how to multiply by a decimal and divide?
Yes.
Look at all those things that we had to do. So what's going to come first here? What has to be done first? Carter.
We have to add 7 plus 11.
What do you get there, fella?
18.
18. So now I have 18 times 2.5. What do you get when you take 18 times 2.5? Phoenix.
45.
45. So now I have 45 divided by 2. What is our answer, Rachel? You want to whisper it to your neighbor, see if you're right? Check with your neighbor. Does your neighbor have it? Check with this neighbor over here, because I know they have it. Check with them. Is that what you got?
22.5.
22.5. Good. And what did I label this as? So don't I have to label it centimeters? So if I was to give you another problem here, can you find the area of that trapezoid? When you have the answer, you give me a thumbs up, I will come check it, and I will know that you are ready to move on. Got it. Got it. You're close. Try again. Which is our height here? There you go. There you go. What's our height? Look at it again. Can the slant be a height? Do you want me to take your height that you're leaning up against the wall? No.
I did the same thing.
Oh boy. Kids have walked around, you know what I've noticed? I've had a lot of kids tell me that this is the height. Would you want me to take your height if you're leaning up against a wall?
No.
Or would you want me to stand up straight? Stand up straight. You don't want your height leaning against a wall. Yes, you got it. Close, not quite. You got it. Got it. Yep. Yes, I think we've all got it. Okay, so now what we're going to be using is we're going to have to know how to find surface area. So if I gave you so now you would have to use this if we were finding surface area. For example, what if I gave you a problem that looked like this? So that is where we are going to be going with this. You should know how to find the area of a square. You should know how to find the area of a rectangle, a triangle, and a trapezoid. Does everybody agree with me?
Yeah.
And a parallelogram. So when we are finding what we call surface area, what if you get something that looks like that? Are you gonna have to know how to find the area of that trapezoid? You betcha. Okay, so you can put these away, and then you can get all your stuff for your tin person.